Hey everybody, welcome to my chat on multi-architecture CI/CD with OpenNebula. I'm Ken Van Alstyne and I'm the CTO at SOFTIRON. It's been a long time coming. I was really looking forward to seeing everybody in Brussels, and that just didn't pan out. I had a great time at the last OpenNebulaCon in Barcelona, and I'm really going to miss seeing everybody this year. For everybody I didn't meet in Barcelona, there's been some, or even for the folks that I have met, there's been a few changes. I was the chief architect for the cloud and application services at Peraton. They're a fairly large US defense contractor. At the time, I was working for a company called, at the time that I spoke last at OpenNebulaConf, I was working for a company called Perspecta, and they were acquired by Peraton. I joined SOFTIRON as the CTO in August of 2021, so I'm still a little green in this seat. I live in the East Coast of the United States, and as I alluded to, I'm really going to miss the OpenNebulaConf after party. For the folks that were there last time, I think you know what I mean. So a little bit about the company. This is the marketing pitch. Basically, we build scale-out data center appliances for pretty much anybody, private and public cloud, enterprise scale facilities. Some of our larger companies tend to be service providers. We have a focus on density, efficiency, capacity, speed, and heat emission. Something that's pretty unique about us is that all the design, firmware, and manufacturing is done in-house in Newark, California. We have all of the source for our BMC, for our EFI, even for the operating system that we run on the system on chip. Additionally, we're one of the only manufacturers that makes our own BMC in-house and uses that for our, our IPMI interface and baseband management controller for the whole box. Incidentally, we're also going to be opening up another manufacturing facility shortly in Sydney, Australia. So we'll be manufacturing boxes in both Newark, California and Sydney, Australia. The non-marketing pitch, you may have heard of SOFTIRON in the past. We've been on a few pieces on Slashdot and some other technology news sites in the past, talking about our ARM development boxes called the Overdrive. So some people know us as the ARM computer company. We've diversified a little bit since then, and we make several product lines now. We have the Hyperdrive, which is our best-selling product. It's a Ceph-based storage appliance. We have some of the more density and heat-sensitive and power-sensitive nodes on the ARM64 architecture. And then some of our storage routers and our high-performance like NVMe storage is on x86 on AMD EPYC. We also have HyperCast, a hardware transcoding appliance, and then HyperSwitch, a sonic-based high-performance switch, typically deployed in conjunction with Hyperdrive. We have some other products in development as well. Hopefully some using OpenNebula, but I don't necessarily have the ability to go into that product line at the moment. So why OpenNebula? Why bring OpenNebula to SOFTIRON after I joined? Well, number one, I'm a bit of an OpenNebula zealot. And why is that? Well, some of my favorite reasons are here. There's a documented and consistent API. It's super easy to integrate with, super easy to use, and it's extensible. Right? I mean, it's OpenNebula is one project as opposed to an integration effort with lots of things like say OpenStack. And then there's the existing ecosystem as well using that API like Terraform, Ansible, Chef, Puppet, Salt. The wide virtualization technology support with containers, virtual machines and micro VMs. Something somewhat unique with OpenNebula is how easy it is to be CPU architecture agnostic. And then of course some of the other more advanced things in OpenNebula like OneGate and OneFlow. So how is that relevant to us? Well, there's a few unique properties of our environment, as I alluded to in a prior slide. All of the software, including our UEFI and BMC firmware, is built from source in-house, often with very specific development toolchains that are incompatible with other projects. So we need to spin up basically a development box or a build box just for some of these individual projects. We don't want to leave those boxes just laying around consuming resources. We'd rather spin them up when we need them and terminate them or destroy them to free up those resources for other projects when we can. And then, of course, we need to perform continuous integration and regression testing of software across multiple OS and CPU architectures. So that needs a couple of things. We need full system containers on both ARM and x86. Why do I need full system containers? The biggest reason is when I need to do nested virtualization, which is effectively broken, especially on AMD EPYC. When you're trying to do virtualization inside of a KVM VM or double nested virtualization, things get really broken. And then virtual machines on ARM and x86. Even doing some Windows on ARM64, which is a little unusual, but works just fine on OpenNebula using ARM64 KVM templates. So in short, internal only today. We're looking at possibly using it in a product in the future, and hopefully by the time we chat again, I'll have something I can announce to the overall OpenNebula community. So some very specific ways that we use the product today. We have GitLab runners. That's probably the most robust process that we have that uses OpenNebula. When we have a software commit, especially in when a major release is tagged, the GitLab CI process kicks off with a GitLab CI script. One of the first things it does is it deploys a virtual machine, even or especially Windows boxes via the API. The image has all of the things that we need to do the workload inside of it, like the GitLab runner software, the build toolchain, OpenNebula contextualization. On boot, that new GitLab runner provisions with the GitLab server. And then the next step is the build process kicks off for the software, and the artifact is uploaded. And once that artifact is uploaded to the centralized storage repository, the VM is then terminated via the API. Another interesting way that we use OpenNebula is software regression testing. We don't necessarily talk the API directly or use the OpenNebula CLI tools for that. We have Terraform that deploys virtual machines to perform the regression testing so that the VM boots up after being orchestrated with Terraform and executes a run script that's defined in the context for that VM to install software and perform client-side testing. Something interesting is that the run script doesn't necessarily need to be a local file. It can be something hosted, say, on a reachable web server. So after network contextualization completes, the run script gets executed. And that run script can be something in, again, on a web server or in a version control repository. So you can keep that script up to date over time with changes that you need for that CI/CD process. And you can then take, the run script's exit status as whether or not the regression test, passed or failed. So after completion, the status is reported back, and then the environment's cleaned up via the Terraform integration. So a little bit about how we, split up the various hypervisors and architectures. Probably obvious if you've played with OpenNebula templates, but I just wanted to point it out. I just put all of the hosts, all of the hypervisor hosts, whether they're LXC, LXD, KVM, I put them all in the same cluster, and I rely on the template with the SCID requirements to deploy them on the correct host. So all you have to do is change the arch to either x86-64 or AArch64, or the hypervisor between KVM and LXD. LXD is the example I'm using in this one because we're still on a fairly older version of OpenNebula in this environment. So we're doing LXD rather than LXC, but the concept is roughly the same. So I'm going to hop over to Sunstone and give a little bit of a demo of the environment. All right, now that we're in Sunstone, we'll just give a little demo of all of that in practice to show that it's real and not just theory. So we'll play with our SOFTIRON Linux container and VM templates here. SOFTIRON Linux is our Debian-based stateful operating system that we use when a stateful OS is needed. So if we look at, for example, the SOFTIRON Linux x86 VM template, we'll see that the SCID requirements has architecture is x86-64 and hypervisor is KVM. Literally the exact opposite of that. ARM and LXD for the SOFTIRON Linux container on ARM. All right, now we're just going to deploy each one of these guys. We'll start with the KVM virtual machines. We'll do x86 first. We'll call it an x86 VM. Put it on the network that we can reach, with the security group allowing us to ping an SSH into it. The ARM KVM VM as well. the x86 container. That looks good. That already looks good. The ARM container. Also looks good. All right, we'll submit that. And those VM IDs should be created. Let's go over to instances and see where they are. We can see that they're either running or pending, waiting to be scheduled. There we go. Everything's booting up. We can go check out a virtual machine console, for example. That looks good. So I think everything's booted up. Let's go ahead and hop over to a terminal and see if we can ping all of these guys. All right. So from here, we should be able to ping 66, 67, 68, and 69. Those look good. And if we want, we can log into the hypervisor host and see that, for example, we're running containers and virtual machines sharing the same box. In this case, it happens to be an ARM64 machine. And similarly, we do the same thing on x86. We're running VMs and virtual machines, or VMs and containers. And then just to complete the thought, we can see that this is a x86 virtual machine on KVM. I need to clear my SSH known hosts. This is an ARM KVM virtual machine. This is a x86 LXC container. And an ARM LXC container. And that's it. You know, we take advantage of OneFlow, OneGate, the Terraform integration, the extensible OpenNebula XML-RPC API, as well as full system container virtual machine support, and the CPU agnostic nature of OpenNebula to put together a pretty robust build and continuous integration and continuous development environment that we use internally. If you have any questions, I'll be ready to chat with you.